Okay, so this session is special products. This is basically, so this week you were doing some stuff with like exponential, or not exponential, well, exponential expressions with exponents. And then we had adding, subtracting, multiplying, and this is like the second half of 5.6 where you learn how to multiply, and then there's these special products. And I think I briefly covered it in the recording that I have where I did multiplying and I did like FOIL, but I didn't go too much into it, so I thought I would do a separate section just on the special products. Just as a caveat, or not really a caveat, but you don't have to use the shortcuts to multiply these things. So I'm going to actually show you both using FOIL and using the special product. That way you can see that you can get the same answer either way. So you can choose whichever one works best for the way your brain works and if it sees the patterns. So what do I mean when I say special products? So products are things that are multiplied. So these are just special things multiplied together, binomials, which means that they are generally in the form that looks something like this with like plus or minus signs in between. But when they are multiplied together, they always form the same sort of pattern. And so that's what makes them special. Because some of these things, when you multiply them, there's no set pattern. But some of them, they always look the same each time. And so recognizing that pattern allows us to basically take a shortcut so that we don't have to FOIL. But you can still FOIL and get the same answer. So those are what we mean by special products. So I'm going to just start by showing you what these look like and then what the shortcut is. So I've got here x plus 3 times x minus 3. And so I'm going to do FOIL on this. So I'm going to do FOIL on the left side. So FOIL means you first multiply the first term. So that would be x times x. So x times x is x squared. And actually, I'm going to just write this out before I simplify that. Then we multiply the outsides. So that is an x times a negative 3. Then the insides, which is 3 times x. And then the last term, so that's 3 times negative 3. So when I multiply these, x times x is x squared. I get minus 3x when I multiply x times negative 3. 3 times x is a positive 3x, and then 3 times negative 3 is negative 9. And then my middle terms here, the negative 3x plus 3x, those cancel, and so I am left with x squared minus 9. And so this type of FOILing results in two terms. Your middles cancel out. And this is a special type of form where the middles will always cancel out. So this is called the sum and a difference, or you can think of these, another term that we use is to call them conjugates. Basically, they look the same, just the sign in between them is different. That's the only difference, and that's how you recognize these. So I'm going to just use highlights to represent these. So the first term is the same in each set of parentheses, so I'm highlighting that with yellow. And then the last term is the same, but the difference is that they're the opposite in sign, so that's your form. And so that's called the sum and difference because one of them is a sum, is adding, the other one is a difference, you're subtracting. So when you multiply these, what happens is you always end up with a squared term. So I'm going to continue my use of colors here. Whatever you have in the first part is always squared, and then you always end up with whatever is in the last part squared, and you always have a difference between them. They're always subtracted. So that is the form. And so if we look to the left, I'm going to just translate that form here. So the first thing in each set of parentheses is an x. So that gives us x squared. The second thing in each set of parentheses is 3. So that gives us 3 squared. So I'm replacing the x and the 3 according to the form. So if I go back to my highlighter, the first thing is the yellow, so that matches. And then the second part is the green, and so that gets placed in here. So it's a pattern that you're following. So if you look at if you notice the pattern of the colors, and then you simplify, x squared is just x squared, 3 squared is 9. And so you get x squared minus 9. So if you use this little shortcut, you only need to show the 2 steps that I have in blue, and you don't have to show the FOIL step. But you get the same answer. But it's about looking at the pattern and then filling in the blanks to get to the answer. Do you guys have any questions on this example? Let's move on to the second type here. So here I have x minus 3, and then it's squared. So this is called the square of a binomial because you have a binomial, which means we have 2 terms, and then it's squared. So again, I'm going to start by doing this with FOIL. And when I do that, I write it twice. So that means I have x minus 3 times x minus 3. So then I go through the FOIL process. So the first terms, that's x times x. Then the outside terms, so that's x times negative 3. The inside terms, which is negative 3 times x. And then the last terms, which is a negative 3 times negative 3. So this looks very similar to the example I just did. That one I had one with plus and one with minus. Here they have the same sign. So that gives me x squared. And then x times negative 3 is minus 3x. And I get another minus 3x. And then negative 3 times negative 3 is a positive 9. So it looks similar to the last one, but the signs are different. And so when we simplify here, I got x squared. I combine my like terms. In this case, they don't cancel. Instead, they combine, they add. A negative 3x minus 3x is minus 6x, and then plus 9. And this result is what we call a perfect square trinomial. That will come up again next week or when we start week 6. But that's how you find that with FOIL. So you first write it twice because that's what the exponent means. And then you go through the FOIL process. Now I'm going to go through what it looks like when you have the pattern, if you're just looking at the pattern. So I'm going to use my highlights again. So the first thing is going to be yellow. The second thing is going to be green, and then this is with a minus, and then they're squared. So when we use the shortcut here, you get the first term, the yellow part. Oops, I meant to do that in highlight, not pen. You get the yellow term squared. Then you get minus 2 times the middle, or both the yellow and the green. This is an interesting pattern. But you have both the yellow and the green, and they get multiplied together to form the middle term. And then the last term, you always have a plus, and then it's the green squared. So The pattern is different from the previous example because while the first part and the last part look similar, but the last one has a plus this time, we now have a middle term. So it's 2 times the two parts together. So if I'm using this shortcut with my example here, and that would be, so I would have the yellow part squared. Our yellow part is x, so that's going to be x squared, minus 2 times the yellow, which is x, times the green, which is 3, plus, and then the green, which is 3 squared. So I'm following what I've highlighted in my original problem. Then we simplify. We get x squared. Then I have negative 2 times x times 3. So we do negative 2 times 3, which is negative 6. And then I have the x. And then 3 squared is 9. So that's plus 9. So you get the same answer. It's fewer steps, but you have to notice the pattern. So you can see that if I use the shortcut, that's basically 2 steps. If I FOILed, I have 4 steps written down. But you get the same answer either way. Do you guys have questions on this example? Where did the negative 2 come from? So that is part of the shortcut, and that's because if you're looking on the left side, we have negative 3x and a negative 3x. There are 2 of them, so that's why we multiply it by 2. And the negative comes from because we know that both of those parts are negative, so our result will be negative. So it's just taking the left side and noticing that you have the same thing twice. And so that's why we have the 2 there. And that negative comes from the sign because it's basically you have a minus 3 in front of there. So that's where that minus comes from. Are there other questions? So moving on, example 3. So this is also square of a binomial, but notice this one has a plus instead of a minus. So example 2 had a minus, this one has a plus, but it's going to look very similar. So I'll start with FOIL, which means I have to write this down twice because of the exponent is a 2. And then I'm going to multiply first, that's the f, so that's 4 times 4. Then the outside, so that's 4 times w. The inside, which is w times 4. And then the last terms, which is w times w. So then 4 times 4 is 16. I get plus 4w. W times 4 is another 4w. And then w times w is w squared. Then the middle terms here, so the last example, example 2, went with a minus. We ended up with a minus, but now these are going to add. We have 4w plus 4w, so that's going to be 8w. So we get 16 plus 8w plus w squared. So that is using FOIL. So if I have something like that, if we're going to look at the pattern, I'm going to make my first term yellow, the last one green. The pattern is that you get the first one squared. That's a common pattern for all of these. And in this case, we end up with plus 2. Instead of a minus 2, it's plus 2 because now it's a positive in there. So it's 2 times the yellow and then times the green. And then the last term is plus the green squared. So it's very similar to example 2, but that had a minus when we started, and so that had a -2. Here, this has a +2, but everything else looks the same. So if I was to use this pattern with this particular example, with the 4 plus w squared, so the 4 is going to be the yellow, and the w is going to be the green. So I get let me change that color. So the yellow squared, so that's going to be 4 squared plus 2 times the yellow, which is 4, times the green, which is w, and then plus the green squared, so that's w squared. And so then I simplify. 4 squared is 16. In the middle, I have 2 times 4, which is 8w, and then w squared. So again, I get the same answer. It's only 2 steps with this shortcut as opposed to basically 4 with the FOIL method, but you get the same answer either time. And so that's the key, is that you can use either one of these. I use the shortcut, but that's only because I can look at these and I've done multiplying of these so many times that it's faster for me to do the shortcut because I've basically memorized the shortcut. But you guys are just learning this stuff, so I'm not expecting this to be easy for you because you're just learning FOIL and now we're throwing a shortcut. So if you can see the pattern and it makes sense, go ahead and use the shortcut. But if you don't have to use it. I'm just providing it to you because sometimes people really connect with it and it makes sense with them, but some don't. So do you guys have any questions on this example? Okay, you guys are quiet. I don't know if that's a good thing or a bad thing. Okay, so here is the summary. So this is how the formula is given in the book. So this is a screenshot from the book, and they use A's and B's. But a lot of people get confused once we throw in variables, so that part's confusing already. So that's why I do the color coding. So I'm going to just color code these. Everywhere you see A, that's my yellow that I was using. And so I'm going to just, if the colors work better for you, then you can just follow the colors. And then I'm going to do the green. So for me, the color helps me see the pattern. And you can kind of see that there's a pattern in all of these. What matters is the sign, and that sort of determines what the result looks like. So you can have these written down somewhere, but again, if this is hard for you to use, you can do FOIL every time. Now I have, let's see, I think about 6, 7, 8, 9, 10, four examples going forward, and I'm going to use the shortcuts so that you can see them be used. And then again, I'm going to show it with FOIL so you can see the back and forth. So I'm going to show it both ways, just like I've been doing, just so you can, that way you can see that you can do it either way. So this first one, example 4, I'm actually going to do the special product first because the first 3 I did the FOIL first and then the special product. So let's do the special product and then we'll FOIL. So because these are the same, they just have different signs, this is going to be the sum and the difference. So I'm going to just highlight there so you can see the yellow and the green. And then I'm going to write the pattern again. So this is the pattern. Whoops, that's supposed to be a minus. Whether the plus is first or the minus is first, it does not matter. Just as long as they look the same, but they have the opposite signs. So if I use the shortcut, I'm going to put my yellow part in parentheses, and then that's squared. And then I have a minus, And then the green part, which is the 7x, that is squared. So that is following the pattern here. So my yellow is the 5y, and then the green is the 7x. So I've just basically stuck them in where they belong according to the pattern. Then I'm going to follow my rules of exponents. So when I have 5y squared, you square everything. So you square the 5, which is 25, and you square the y. So that's going to be 25y squared. Then I have a minus. Now I need to square both the 7 and the x if the whole 7x is squared. So 7 squared is 49, and then x squared. So when we have that exponent and we have several things outside, that exponent kind of distributes to both of the items. And so everything in there gets squared because it's on the outside. Just like when you distribute, everything on the outside gets multiplied by the inside. Here it's the exponent. Everything on the inside gets that exponent from the outside. So our answer is 25y squared minus 49x squared. Before I move on and do FOIL, do you see the pattern there and how that worked? And how I just kind of plugged in the numbers and then I squared them. Oh, there. You see this one now. This was understandable, but okay, now it's telling me you're typing. I think there was some issue with it wasn't showing me whether you're typing or not. So if they're all going to be squared, you're asking, are the front and the back going to be squared? In this form, yes. So if you see the same thing multiplied by itself, but the only difference is one has a plus, one has a minus, yes, the front and the back are always going to be squared. And actually, the front and back are always squared in all of these. It's what happens in the middle that changes. Do you have any other questions? Okay, ask away. In this case, the sign comes because we have a plus and a minus. So positive times a negative is a negative. So if they were both plus, like when they're squared, that's how we end up with the thing being a plus there. If they're both minus, we still end up with a plus because a negative times a negative is a positive. So when you look at those middle, the signs that I have that I've not highlighted, that tells you the sign in front of the last term. So we have a plus times a minus, so the last term is going to have a minus because a positive times a negative is a negative. Yeah, the signs can get confusing. It gets better with just practice and maybe just telling yourself positive times a negative is negative, negative times a negative is a positive, and of course when you add it's different, so you have to determine whether you're adding or multiplying. But if you follow the pattern and you follow the signs, you should be okay, because this is basically you're just filling in the yellow and the green, and the sign is already there for you in the shortcut. Are there other questions? Okay. Feel free to stop me. I will be checking for more questions. So going back to, so now that we've gone through the special product, I'm going to go through and do the FOIL. So I'm going to just rewrite it so I can show the FOIL part. So you can see that we get the same answer. So I had the first terms multiplied, so that's 5y times 5y. Then the outside is 5y times negative 7x. Then the inside, I'm running out of room here, I'm going to have to, 7x times 5y. And then the last terms is a 7x times negative 7x. So then I simplify. The 5y times 5y, 5 times 5 is 25, and y times y is y squared. Then I have 5 times negative 7, so that's negative 35, and then I get a y x. Then the next one I have 7 times 5, so that's plus 35. And this has x, y, but these are the same because they have the same variables with the same exponents. They both don't have any exponents. And then the last term, I have 7 times negative 7, so that's negative 49. X times x is x squared. So even though I have yx and xy, the middle still cancels because those are still like terms. So you get 25y squared minus 49x squared. So that's what it would look like going through FOIL as compared to the special product, which is, it's a shortcut because you don't have to write so many steps. Okay, so now I'm going to go through example 5. This is very similar. It's going to be using the same rule. This time I wrote it with the minus first instead of the plus, but it's the same rule. So the first thing is going to be my yellow, and then the last thing is going to be my green. And then we have the rule. I'm going to put the minus first here, but it doesn't matter. The result is still going to be the same. So I'm going to go back and highlight so you can see the pattern. So even though I have a minus first and then the plus, the pattern is the same. So that part does not matter. What matters is whether they are opposite, with one of them positive and one of them minus, and then they look the same. So when I use this rule, I'm going to have the yellow squared. So that's going to be 8w squared squared. So I picked this example because I already have a square in there. So I wanted to show you what happens with that. And then the green is just x. So I'm going to go back. Whoops. I thought I still had the, there we go. So the yellow was 8w squared. And then the green is x. And now I have to distribute, use my rules of exponents. So I square the 8. 8 times 8 is 64. And then when you have w squared and you square that again, you multiply the exponent. So that's w to the 4th. Then we have x squared. So I have to actually square the number, and then you multiply the exponents when you have a variable there. And you have a power, you have an exponent with another exponent. Those get multiplied. So 2 times 2 is 4. So this is basically the same one that I just did. Still has the minus in between. It's just a little more complicated to show you what to do when you have those other exponents in there. Now, if I'm going to do this with FOIL, I'm going to try to write smaller here so I have more room. So I have my first terms, 8w squared times 8w squared. The outsides, which is 8w squared times x. The insides, which is a negative x times 8w squared. And then the last terms, which is a negative x times x. So I simplify, I have 8 times 8, which is 64. And a w squared times a w squared. In that case, when you're multiplying those, you add them, you still get w to the 4th. Then I have 8w squared x. Then the next one, the negative gets multiplied by the 8, so that's minus 8xw squared. And then I get minus, because I have a negative x times x, so that's going to be negative, and then that gives me an x squared. So the 8w squared x and the minus 8xw squared, those are like terms because they both have x with no exponent, and they both have w with a 2. So those cancel because 8 minus 8 is 0, and we get 64w to the 4th minus x squared. I actually think that when you have complicated polynomials like this that you're multiplying, that it's harder to use the FOIL method, and that the special product is easier and neater, and you're less likely to make mistakes, because a lot of people get confused once you have like a w squared x and an xw squared. The special product doesn't worry about any of that in this particular case, and so I think it's actually easier to do. Are there any questions? Okay. Now here's example 6. So this is the square of a binomial. And so this is a different kind, this is the other type of special product here. So let me highlight. Got my green, which is always the last one, and the yellow, which is the first thing. So this form, we have something minus something, which is something squared minus 2 times each something plus the other something squared. I know that's a lot of somethings, but I gotta fill in all my highlights here. So in this case, when they're squared, you have the first term squared minus 2 times both of those multiplied together, and then plus the last term squared. So when I put this in special product form, when I use the shortcut, my yellow is 5d. So I have 5d squared, then minus 2 times the yellow, so that's times 5d, then times the green, which is 9, then I have plus the green squared. So that is plus 9 squared. So I'm going to just highlight these so that you can see. I'm just replacing the highlights with the correct part. Then I simplify. So 5d squared, I square the 5. 5 times 5 is 25. And then d squared. Now in the middle, I'm going to have a minus, and then I have 2 times 5 times 9. So 2 times 5 is 10. 10 times 9 is 90. So that's going to be a 90, and then I have my d. And then 9 squared is 81. So I get 25d squared minus 90d plus 81. And that's using the shortcut there. And just plugging in my things, my expressions, I guess, the 5d and the 9, into their matching areas to follow the pattern, and then using the rules of exponents on them. Okay, let me go through this by doing FOIL. So I'm going to first write the 5d minus 9 twice because it's squared. And then I'm going to have my 5d times the 5d. Then the outside is 5d times negative 9. The inside is a negative 9 times 5d. And then the last terms, I have a negative 9 times a negative 9. So 5 times 5 is 25, and d times d is d squared. Then 5 times negative 9 is negative 45d. Negative 9 times 5 is negative 45d. And then a negative 9 times a negative 9 is a positive 81. Now in my middle, I have like terms, so that's going to be 25d squared minus 45 minus 45. That comes to negative 90, so that's minus 90d, then plus 81. So the same answer as using the shortcut. And then this is my last one. I made this one a little more complicated. I have exponents upon exponents again. This one has the plus, but we still have something squared, so it's going to be very similar. So I'm going to highlight my yellow and my green. And so this will be something plus something squared is the first term squared plus 2 times the first times the last plus the last squared. So I'm going to highlight everywhere where the last term shows up in green, and then the first term is going to be in yellow. And you can see that the pattern looks very similar, but now we have a plus 2 instead of a minus 2 because we have a plus in between them. So I'm going to start by using the shortcut. So I first start with the what's in yellow squared. So that's going to be u squared squared, then plus 2 times the yellow, so that's times u squared, then times the green, which is 4v, then I have plus the green, which is 4v squared. So I'm going to just highlight those so you can see the pattern. So u squared squared, when you have exponents like that, you multiply. So 2 times 2 is 4, so that's going to be u to the fourth. Then the middle term, I have 2 times 4, which is 8. Then u squared v. And then the last term, I have 4 squared, which is 16, and then v squared. So you end up with u to the fourth plus 8u squared v plus 16v squared. And that is using the shortcut. I just plug in the numbers or the variables in this case, and then I simplify. Now to compare that to FOIL, it's u squared plus 4v squared, so I have to write it twice. So I multiply the first term, so that's u squared times u squared. Then the outside, so that is u squared times 4v. Then the inside plus 4v times u squared. And then the last terms, which is 4v times 4v. You have to be very careful that your u's and v's don't look the same. That's why I put a little curl under the u, but not on the v. So u squared times u squared, you add the exponents in that case, you get u to the fourth. And then I get 4u squared v plus 4vu squared plus 4 times 4 is 16. V times v is v squared. Now the 4u squared v and the 4vu squared are like terms because they both have a u squared and they both have a v. So those can be combined. So 4 plus 4 is 8. So we get u to the fourth plus 8. And then it doesn't matter which one you write, but I usually do the u squared v plus 16v squared. So you get the same answer as using the shortcut, just with more steps. Okay, I'm not seeing any questions. Again, If this method is, if these shortcuts are confusing to you, you do not have to use them. This is an option if it makes sense to you, but it's not required. So, oh, let me adjust this so you can actually see me. So yeah, if it doesn't, if you're struggling with these special products, don't worry. You don't have to use them, but it will make your life easier next week. But it's not. I mean, you can see it's basically half the steps. It's 2 steps versus 4. That's not that many steps you're saving. So it's not like a huge time saver. But if if you're looking for ways to make things go faster, that's something that you can do. So if you guys have questions, you can email me, chat me, give me a call. The next, let's see, Wednesday, let me bring up my calendar. I'm going to do the introduction Wednesday at, let's see, was it 6 o'clock or 5? 5 o'clock on Wednesday. And then Friday at 1 p.m., I'm going to do 6.5, which is the difference of squares and perfect square trinomials, which is basically doing the opposite of what we just did. So it's like we're going to be factoring starting on Wednesday, and there are special ways to factor. There are shortcuts to factoring, and so that one will be basically showing how you can do the opposite of what we did to go backwards. So they're going to be kind of go back and forth there. So that's all I've got for you. So thank you very much for joining. And of course, if you have questions, let me know. All right. I will talk to you later.